Okay, so this time let's build another data structure. This will be a tree, and then we'll convert it to a trie to implement autocomplete. Basically, a trie, let me show you on Wikipedia trie. So a tree is basically like the linked list that we made before, but instead of having only one neighbor, we'll have a list of neighbors, okay? And in a trie, the idea is to have like a letter, let's say, for each connection. And then to make autocomplete, we'll have to also get a list of words and then in each node say if it's a terminal node or not. So if it's a terminal node, then that the path from the root node to the end node is a word. Okay. So yeah, let's try to build this tree structure, and we'll do it again in C. Why not? And yeah, so again with the main.c file, not to forget to increase the font a bit, just in case. So yeah, like hello world first. Okay, so as I said, the data structure that we'll make is really specific now. So uh, how we did before was let's call it also node, and here the idea is that we'll like before we had this next node, right? But now we actually want to have like more neighbors, and I mean we can call this children, right? And I think it's 26 letters, right? I mean, let's do only lowercase, and we'll convert all the words to, like all the names to lowercase and so on. So it's easier. And the other thing that we need might be like an unsigned, like a boolean, but I mean it's C, so we have this, and we have a field that tells us if it's the end of a word. So yeah, this is how the node structure looks like. And to make things easier, let's make another structure called trie, which will have a reference to the root node. So basically what we need now is a function that creates a trie new, say, and yeah, basically this we need to allocate it. So we need stdlib. We need to allocate the trie, like the structure, and yeah, I guess we also need to allocate the root node. And I think that um, probably the problem with using malloc is that we need to iterate all the children and all the like this variable and make them 0, right? Like if a child here is null, then it means that that letter is doesn't have like a follow-up. It's not in our vocabulary. So I'm not sure if it's a better way than using calloc. Um, like calloc, I think initializes everything with 0, right? So and it's also like it takes in the number of members. So it would be like 1, right? And the size of the member, so it would be this. Yeah, anyway. I mean, we can also create a function struct node pointer node new and have it like use malloc and then initialize each child with null and is end of word with null. Okay, so we can also do that. And yeah, I mean, you also should like check if malloc works and such. But well, for now, let's say that we don't really care about that. And yeah, I mean, let's define alphabet size, and instead of 26, let's use alphabet size. Okay, to not hard code any numbers. Okay, so we have now we can have a try. So create a new try. Now the next thing that we need for our try is a try insert basically, and yeah. Okay, I mean, let's implement this ourselves. It's a bit weird. So this function, well, no, like you can make this function static because we use only, but yeah, I don't really care about it. I wanted to define these at the top just to make sure that everything is fine. And yeah, if you type here static in front of a function, you basically, if I remember correctly, you make it so that it's defined only in this C file. So if you include somehow this file in another file, it's gonna be used only here. Like you say that. I don't remember if that's the case, but we don't really care about that either. So yeah, now that we have the node, let's make a small function here that we make a chart to index for character C, and yeah, like Copilot is right. We are gonna subtract from our character the character A, and that gives us the index. So like for example, I mean, wait, what was I doing? Yeah, I wanted to make a test.c file and like showcase that. Include stdio. Okay, and let's say that we have a char c. Let's say it's b. Let's make it like g. Well, easier like this. And let's do this. Okay, and let's see. So main. See, like it. I mean, it works. I don't know why I tested it. Okay, so basically this is how we are gonna index into our list here, right? And what's good about knowing the alphabet size beforehand is that this will be static. Like we can use the dynamic array thing, but it's not really needed because we know that all the characters will be between 0 and 25. It's 26 characters. So yeah, now we have to iterate through the word. So what I would like to do here is, let's say, character C, just to like, because it's more fun this way. C++. Okay, so basically we take a pointer, like it's just a copy for a word, and when you do C++ on a char pointer, you just move the uh, starting position to the next character in the string, right? So if we reach the end of the string, it will be a 0, okay? And if we dereference C now, we are gonna get the character from the string that we want to see, that we want to use. So we can define here an unsigned int index and call this, okay? And yeah, basically this check is fine. So if we don't have already a child for this character, then we create a new one, and then we just go to the next thing here also. Yeah, no, I was thinking that maybe it would be cool to have it here, but it's fine nonetheless. I mean, yeah. Yeah, maybe it would be more visible if we say something like, let's say we make a char pointer c equals word, and here it would be like a while c, wait, yeah, while c is not null, and here we increment c. Maybe this looks better, but the for looks also good to me. And yeah, at the end, we have to say that this path was the end of the word. Okay, so now we can insert words in our try, and yeah, now let's implement a function that just gives us one suggestion. Like based on a prefix, it gives us the first word that it can create using the try, like the data from our try. So let's have here try suggest struct try t, and then we have a prefix. So like we did here, we need this. Okay, first we need to do something similar to this for loop. So but yeah, I mean here is prefix, we need to index everything. Yeah, so if the child is null, then that means that we cannot have a suggestion. It means that this prefix is not in our vocabulary, so we can just return null here, and otherwise we go further with our search. And yeah, now the interesting part here. So how are we gonna, because now we need to do, I guess, some DFS on the try, and we might also need, but not yet, to get the vocabulary of words that we are gonna use. Yeah, so let's make an, let's say, auxiliary function pointer try, um, let's call it BFS, I guess, and this will get a pointer to a node. Well, it's a node, not a try, and what I was thinking this function should do is like first word, maybe. Try find first word. Okay. So basically we are gonna loop through all the children. Okay, so okay, so I guess this will return us the not really the first word, but the suffix that will combine with the prefix, right? Like what's needed to add to the prefix to make the word. So first of all, if I mean yeah, whatever, if n is null, then yeah, it's a check. But if n is end of word, and something yeah that I missed here is that we need the well yeah, we can also build the word, right? And here I would return the prefix. Okay, I mean this is kind of impossible, but who knows? Who knows? Hmm. Yeah, because I was thinking that, well, if a node is null, then I don't even visit it, so why have that condition there? Now, let's go through all our letters in the alphabet size, I++, and yeah, basically if, as I said, if the child is null, then we don't even care about it. Well, how do we know that it's the first result, right? Like, what if we need to get all the possible suggestions instead of doing a depth first search and doing like some sort of a breadth first search and get all the, because even if we find one word, how do we tell the others to stop, basically, is what I'm thinking. So maybe this should be more like, this should be like a void, and instead of having here just this, what we have also suggestions like this. Trie find words, or I mean let's call it words. Why do you need this? I mean, who knows, who knows. So yeah, basically let's just print it for now, actually, and I'll add the dynamic array implementation here to add to the suggestions, but for now let's just print it. Then yeah, I mean the problem is, I mean the sad thing in C is that you can't easily add a character to another word. We have to str dupe this, concat it with the character, and then use it. So if n children of I is not null, let's delete this. Okay, so if it's not null, then we can actually use it. Alright, so we can make the other function now, char index to character. So here it's enough just to add I to the character A and convert it back to a character. So yeah, now we have yeah, I like this approach better. So we allocate the new prefix with this +2, this size +2, because we need to add um, our new character at the end. Okay, like this. And then we need to also add the 0. And then we just do this. So yeah, I mean, this just prints the suggestions, but I'll copy it afterwards. Now, wait. Yeah, I mean, let's just make it void again. That doesn't do anything, and basically this function is also like this. And this would be again like a private function that's like helper function for this one. So yeah, like let's test it a bit with some random words. That's funny. Okay, anyway, let's try to find words and let's go for, let's use W here, see what happens. Oh, I meant the main. Let's see. Yep, that's that's looking really good. Okay, what was the mistake then? I'm really curious. Oh, I forgot to call the, I forgot to call the thing here, right? Like what? It was, yeah, anyway. Yeah, let's call this one actually node because it's done on a node, not on the try. And now let's see. Okay, so it finds the correct word. Now what I wanted to do is let's create a Python environment first and source it. And what I was playing with a bit earlier was NLTK. Okay, import NLTK and, or I guess from NLTK import words. So in this yeah, I don't really remember. Oh, it was in NLTK corpus. Yeah, like, and if we try to use this, it's not downloaded or something like words. If we try to see how many words we have, oh, it actually I mean, I downloaded it a bit earlier, so it's already cached. So we have like quite a few words, and yeah, if we take a look, like the first 5, first 10 words, they also have like these names, right? So not really an issue. So yeah, basically we can copy these words. I think they are like txt files. So let's go into home, data, corpora, words, and here we have like, yeah, and they are like text. So let's copy this. What was it? Autocomplete. Okay, let's have it there. And yeah, basically now a good question is how do we read a file in C? So mm, I mean, I guess it's probably since like maybe reading them one by one, like one line at a time, could be some idea. Instead of like making an array and just doing the insert. So let's have like void try from file, and let's give it the file name. Well, it makes sense to have the try first. File name. So yeah, we might need a pointer and use fopen. I think this is in stdio. Okay, fine. So it's good. But what I'm not sure is how do you read only one line? So C read line. Is there something like this? There's this thing get line. I mean, to be honest, I would try it. Um, or using fgets. Like, is fgets a thing? Anyway, I mean, let's say that I don't think it's possible to have words longer than this. I mean, even that it's a bit long. 256. Anyway, yeah, I mean, again, like handling errors, it's not something that we are gonna do on this channel. It's going full degenerate mode. Okay, so let's it's like not doing your warm-up before your heavy sets in the gym. It's the exact same thing, the exact same thing. Yeah, so I mean, this guy is giving it to us. I really like it. Yeah, I mean, first let's print this thing, and also fclose. I mean, we are not that down bad. I mean, we at least close the files and free the memory that we allocate. Well, that's a lie, I guess, because we didn't implement try free. Let me do it. Free. Well, I mean, ChatGPT, come on, like actually Copilot, but this is a bit sad because it's not really well. Let's also make void node free. Node pointer n, and so this goes through all the children and frees them like recursively. Then we free the current node, and yeah, that means that we can also free all the children. Now it's fine. So let's do here try free. God damn it, and return a 0. So now let's compile the thing. Okay, still works. And if we do val grind main, damn it, I don't know why I have OCD and I want to free everything. Probably some memory is lost when we allocate this thing, right? Like maybe you want to realloc prefix instead of malloc, but even then it's like what do you do when you have like the first uh, thing here, right? Like you might have to say something like char pointer new prefix and uh, just at least str dupe it and then send it, because otherwise how do you free the and it's still well just because here we don't free it, right? Like we should free prefix here. So now like I don't really like this way of doing it because we do an alloc extra, but how can you tell if prefix is already a pointer or not, right? Like that's the only thing. It sucks. It really sucks. Strings in C are really bad. But yeah, I mean, we don't really care about this. So let's do try from file, and let's just move en to words.txt. I mean, it's gonna be bad, but it's gonna be too many words. What the hell? It was so quick. Jesus. Holy shit, dude. Wait, can I do something like /dev/node just to see how fast it... Bro, holy shit, it's so fast, dude. Holy moly. I mean, to be honest, I was expecting it to take a lot longer. Even like crash my PC, but pretty good. And yeah, I mean here, let's insert this bad boy. And Yeah, now we can try suggest a. Well, um, holy moly, this is like a really cool function. I've never what's strcpn. Oh, it was so cool. I closed my Vim. Hey, it's like a search. But why do you need to do it like this? Why not like strchr? Like, why not like this? Why use random? Anyway, so yeah, something else that I wanted to do is like convert all the characters to lowercase characters. So how would I do that? So let's say char pointer lowercase, another char pointer word, and okay, so basically we convert this to lower, and this is actually a function ctype.h. Hopefully it works. Yeah, so and at the end we just return the word, and I did it like this just because maybe you want to call it here like lowercase buffer just to not have any issues. So let's see now. Ooh, that's nice. Was it maybe because, yeah, it was because of that. Let's see the word. Let's see the word. Oh my god, it's a minus. Oof. Yeah, I was thinking that okay, let's have another function unsigned int valid word. Okay, and is alpha is again C type. Really interesting. Alpha means like alphabetical, like no letters. Anyway, so here we can say if it's I like continuous when I program in Python and other languages, but in C I don't like them. I don't know why. I think I was brainwashed into it. Ooh, again. Um, well, it's because of the free, right? Wait, where was the function? It's because of that free, and because of doing realloc. Okay, let's just do simply malloc, and here let's do delete until underscore. Okay, because we don't really care about the memory usage right now. Okay, so these are like all the words that start with A. That's really cool. So let's say we do like hell. Let's see what we get, like all the words that start with. Yeah, I was hoping it's only hello, like. Oh yeah, look, it's hello. Yeah, so I guess it would be cooler if we can, like, instead of just printing the suggestions, what if we build like a list of them, right? So let me just really interesting. I thought, yeah, because I have this thing here, which is like really copy pastable. Okay, let's make the font a bit smaller so that it fits. So now in find new words, let's put, actually let's have a structure, and let's call it suggestions. Okay, it will be like this. Yeah, and here we pass the struct suggestions s. It will be a pointer. So instead of doing this, we just da append. If we go to this one, yeah, it expects a pointer, so it's really cool. We just da append the prefix, right? Although what I might do here is actually str dupe the prefix. So because otherwise it will be the same pointer. So if, let's say, we add it into the list and then the prefix changes here, then it will also change in the list, like because it's a reference. So here we also pass s to it, and yeah, I guess then realloc here starts to make sense again, right? Just not to prefix, and then let's str dupe this bad boy. Here let's define our struct of suggestions. Yeah, it's fine to have null there, right? Like the address of this thing. And then I guess, well, I mean, would be nicer to, instead of returning just a char pointer, like instead of doing like this, I think it would be nicer to return suggestions like this. Here we do null, and yeah, now it makes sense here to alloc the thing and initialize it. So now we can do this, and well, why not just return s? Right, and now at the end we can wait, struct suggestions, S, and yeah, now we can show all the suggestions. I mean, it's the same thing, but we keep it in memory. This thing still beats me. I'm not quite sure why. It doesn't like that. I mean, let's try to debug it. Printf prefix. We can figure out the length. There's no way this is a real thing. Heladi, what the hell? There's no way, right? I mean, something's not quite right. I mean, whatever. We can live with some shitty memory management. It's not really a problem. Anyway. So yeah, then we won't need this. Yeah. So basically, if you wanted it, you can even like free S items and then S. Let's see how much memory is wasted. Yeah, like in all those mallocs, like that's so annoying. Well, I guess the issue with what I was doing is that probably we want to free prefix, but we want to free it here. Like we don't want to free it while we iterate because it's we lose it, right? If we do realloc. So that's maybe that's something. Yeah, because we would lose the reference to it. So let's see again. Still some are lost. But not really here because we do free. So to be honest, I'm not quite sure where it happens. Because maybe, yeah, maybe okay, I mean we can also check if we don't do the suggestions, for example, we don't do this part, if we have any memory leaks, but we shouldn't. So like in that place. So yeah, it's really interesting why that is. Yeah, so it's we do like an allocation here for prefix, but it's inside this. Well, yeah, that's interesting though, because if you think about it, wait, if you think about it, it looks like there are 63. So maybe we need to free each item. Maybe if you free like a double pointer, you don't free the items themselves. I mean, actually makes sense. But you know, um, yeah. And now it works. Of course, I mean, I would probably move some something into functions, and yeah, like how about we like what would be like let's say top three suggestions how you would define that? Sort them by length, something, and get the shortest ones. I mean, I guess we can try to do that because in C we have that CQ sort. Let's let's search for an example. And it's still this one. So we can try to sort the the array, and we can try to do it based on the length to get the items in like in the order of size. Yeah, why not? I mean, we can try to do that. So we have the compare function, and oh my god, let's say compare length. Let's say it's in ascending order. I don't know. Don't like the formatting from that weird website. So yeah, basically we have to call strlen on each item and subtract it. And after we have this compare function, we can do like qsort. Probably qsort is in stdlib. Okay, so let's see. So before we print them, before we print the values, let's have this here. So this is cmp length, size of, so we have char pointers. Then we need s items and s count. So this should sort everything by length. Really nice. And yeah, let's say something that you unsigned int top suggestions should be like, is there like a main function? I would say 3 functions. Is this? Hmm. Who knows? Define mean. Like, why not? Okay, and let's go up to top suggestions. Let's have fewer suggestions, like only 3. Okay, that's really nice. And probably the last few things that I would add is like reading the thing from standard input. So char, well, where is the buffer thing? This one. We can have this and say that I don't even remember how, because it's like print f and scanf. Oh yeah, like this, like scanf. Let's print f it. Let's see. You entered what? Okay, it works. So we have the buffer. Put the buffer here, and now if we do this and type here program, we have some suggestions, which is nice. So yeah, basically this is like an autocomplete program. Can we have like this, or is it like really weird where you have to actually type it? Yeah, so I would say printf enter word, then whatever, and here would be like that's really funny. Autocomplete suggestion from Copilot, yeah. So yeah, I don't know, some but it shouldn't be like a typo. It should be more like, okay, let's say translate. Yeah, I mean it has a lot of weird words in that dictionary, but it yeah, it works in some way. It gives you some autocomplete suggestions, so it's a nice program. Yeah, and as I said, some functions might be nice to, like these functions for the suggestions. Probably I would move them, but yeah, overall I think that this project does the job, and it's not even that long. It's like 200 lines of code. We added like maybe 50 lines just to read from file and do like weird stuff, which we don't really need, like sorting the words and yeah, stuff like that. So maybe the core of the project is like 100 lines or 150 at most. So yeah, pretty nice. So yeah, hopefully you learned something from this project that I did, and we'll see next time.